Okay, so in the previous session, we were talking about the quasi-experimental methods. We were talking about this randomization idea, and also we were talking about the problems that might happen if we do not have an experimental design and if we try to use a simple regression method. So we have this idea of indigeneity, and this is something that we have to solve in different ways. And also, we were talking about econometrics. The method that we're going to talk in this presentation is the instrumental variables method, and this is a widely used method. It has some difficulties regarding the intuition. So, what I would like to explain intuition regarding this method, and for this, I am going to use some examples, some visual media to try to clarify what I am trying to explain. And what is an instrumental variable? How does it work? And also, I am going to talk about some technical terms, but I want to clarify and to explain how to use this instrumental variables method and how do we relate this with what we have seen in these previous sessions. So, in that sense, we are going to start with this first presentation or introduction to instrumental variables. So, let's suppose that we have a model like the one we were analyzing in the previous session. And what we have here is just one explanatory variable. So we have one x, and I would like to analyze the effect of variable x on variable y. And this diagram is something that I have already explained in the last session. We omitted the Z part, but we had everything else. So we are going to focus on this part, also remembering what we have seen so far. So we had a model in which X has an effect on Y, and we are going to measure beta, the effect of X on Y. And this is going to be provided by beta 2. So everything was working when there was no relationship between the error and x. So this can be different. For instance, if we have an omitted variable, this is one of the main reasons why we would have an indigeneity problem. So this is an omitted variable because there is a correlation between error and x, and there is also a relationship between x and y. And the key point that we were analyzing is that beta 2, when I estimate this variable, and if I have a correlation problem between u and x, I do not know if I am estimating this problem or if I am just estimating part of the effect of u on x. So this was the context. And now what we are going to do is to try to solve this problem, this endogeneity problem, and also some of the complications regarding a causal interpretation. And to do this, we are going to include a new variable. This is going to be the set variable, and this is an instrumental variable. So what are some of the characteristics of this variable? And set variable must have a relationship with x. It doesn't have a relationship with u. We do not have this thing that is related between both variables. This is not endogenous and it is not related to the error, but this is related to x. Also, it doesn't have a direct relationship with y, sorry. So there is no arrow or something that tells there is a direct relationship between both. The only relationship that exists is through the effect on x. Another way to understand this is, for instance, thinking that Z is not a variable that must be included here. So Z is not a variable that belongs to this specific model. This is actually an additional variable related to X, but not related to U. So when we, for instance, forget that this is an instrumental variable, then this diagram can be very helpful because this is related to X and not to the error, and it doesn't have a direct relationship with Why? So these are some of the assumptions. We are going to talk about the different assumptions and the logic and how do we achieve a good instrument. So before we explain how the instrument works and why does it work for, so we are going to talk about the different characteristics of the instrumental variable. So what we have in the previous diagram, if we want to analyze this in a more formal way, we could talk about the different properties on the instrumental variable. And it has two properties. It has to be exogenous and it has to be relevant. So what does it mean that it is exogenous? It means that it is not related to the error, as for instance endogeneity, that the variable is related to the error. Exogeneity is the contrary. There is no relationship between the variable and the error. So the instrument has to be relevant and exogenous. So the covariance between z and x has to be different from zero. So this is exactly what we had here. Exogenous means that there is no arrow, there is no relationship between u and z. So of course there is a relationship, there is a covariance between z and x. So these are the two properties that we had explained before. And now we're going to talk further on. We're going to talk about some statistical tests in more detail because of course it doesn't have to do with the sessions. So we are going to talk about intuition, which is way more important regarding the instrumental variables, because we need to have a good intuition if the instrument is working or not, and not only regarding the characteristics or the statistics. So that's why I am going to focus on the intuition part. And the best way to express what an instrument is with examples. So we can have simple examples like a textbook example, but I really hope that this helps you to develop intuition regarding an instrument. Then we're going to talk a development topic regarding impact evaluation, because of course impact evaluation is fundamental. But let's start with the simple example that we have here. So I would like to explain the effect of education on wage. So this is a very typical question uh, on this type. I want to analyze the yields. So we need to, for instance, if I have this regression, and under what conditions am I going to be able to say that this beta 2 or the number associated will be the effect of education on wage from a causal point of view? So this was an example before, for instance, a problem with this regression. Maybe we're going to have omitted variables. We're going to have omitted variables, and here we're going to talk a textbook, for instance, ability. So what is the problem, or why do I have an endogeneity problem? Because this variable, I do not have this variable, this was not included in the databases, I do not have information regarding the individual. So what worries me is that ability must have been included. For instance, beta 3 equal to ability, because of course we can agree that of course if you are more able, then your income is going to increase. We will need a statistical relationship here, because of course this is going to have an effect on wage, and this is something very obvious. So we need to have this, we must have this variable, but because we do not have this variable, this is included in the error. But this is a problem because also this might be correlated with education, because maybe some of the individuals with that are more skillful also have a higher also have more education. So for instance, when I want to explain a variable and it is correlated with error, then this is a problem, because I am not going to be able to make a difference if beta 2 has an effect, is measuring the effect of ability and education through wage. So this is my problem and I want to solve this. And here we say that we want to introduce the instrumental variable concept. As you might remember, this instrumental variable must have two characteristics. It must be correlated with X and not correlated with the error, and nothing and not correlated with the error. So in this example, X is equal to education, so we need a variable that is related to education. So in this case, ability is included in the error. In this case, this is a variable that is not related with to the error, but with education. So this is what we need in this case. And we're going to think about some examples. The first two examples are bad examples, for instance, of a an instrumental variable that is not useful, but this is going to help us to understand an instrumental variable. So the first example, and I'm really sorry for the abbreviation here, but this is a sole population registration code. This is known as CURP in Mexico or in Spanish. So this is a number that everyone has. And the specificity of this number has to do with last names, birth date, but the last two digits, and these are the ones that I am referring. In this case, the last two digits are random. So that is the key of what we are using. For instance, imagine a number that is so unique for each individual in a country, and it includes different keys, and the last two digits are random. So what we want to analyze here is that this can be a good instrumental variable, and the way in which we have to analyze this question, if this can be a good instrumental variable or not, is by analyzing if both assumptions are met. So the last two digits of this number, of this sole population registration code. So what do we need so that this can be a good instrumental variable? Well, they have to be related to education, and besides, they have to have a direct relationship with the error, for instance, ability. And they should not have a direct effect on wage. So those are the characteristics. If we, for instance, forget this information regarding an instrumental variable, we can look at this diagram. So the thing that I really need in this case, in this sole population registration code, these two last digits must have an effect on education and not a direct effect on wage, and not a direct effect on ability. So this diagram has to be fulfilled, and we are going to analyze the good and the bad aspects. So this is actually a bad example. So it meets or fulfills the first condition if this is related to ability, or if this is included in this regression regarding wage. So for if we analyze this is random. So if I am saying that the two last digits of this number are randomly selected, then this is just any number, and those numbers assigned for each individual in a representative data sample, then those last two digits are not related to ability. And they are random numbers. So this is exogenous, this is not related to the error, but basically the same reason, and it is a good instrumental variable. This is all this That's why it is going to be a bad variable from another perspective. Why should it explain education? If this is a random variable, then it should not affect ability or wage or education, right? So this is a bad idea. This is not a good instrumental variable because it meets one of the assumptions, but not the other. And the assumptions are very, very specific. They are needed so that the model works. And we are going to see this later on. The only thing that we are doing so far is clarifying what is an instrumental variable, and later on we're going to see everything else. And it is not that easy to find an instrumental variable, because if I analyze this from regarding the exogenous part, then it is very likely that it is not going to be related to X. So there is also a very good reason so that they can be exogenous, and that's why they are not relevant, because they do not have an effect on the variable of interest. So it is very important to analyze this regarding the last slide when we were talking about the instrumental variable, and we have to analyze this from an intuitive and theoretical point of view, and not only regarding the statistical aspects, because maybe in a very specific databases that I am currently using, there is a correlation between these two digits and education, just because. So if I analyze this, maybe I am going to find one variable, and maybe that variable is related to this last two digits. So this is related to education, and from a statistical point of view, there is a correlation. So I cannot say that I have a good instrumental variable. So that's why I mean that we really need to analyze and to have an intuitive part or a theoretical part. For instance, if we go back to the world of programs, how do we apply this to the program or policy? And that's why this is a good instrumental variable. So after, it has to fulfill the statistical part. For instance, if I have this statistical part but not a good reason, then of course I'm not going to have a good instrument. So let's analyze another example. And I am going to give you some other examples. So the first one, we are going to use a proxy, for instance, IQ. So this is a variable that is similar to ability. So remember that the program includes an omitted variable, which is ability. So someone says, okay, I do not have data regarding IQ. So we're going to use this as proxy, or we're going to use this proxy as an instrumental variable. So again, this is not very difficult. How do I know if this is a good instrumental variable? Well, it depends if it is related to education, if this is relevant concerning these assumptions that we have in the slide, and we're going to say if this is exogenous, if the IQ is related to something in to the error, of course.
You are currently the only
variable
person in this
is related
conference.
to education. So these are some of the questions that we have to answer. So IQ is going to be related to education. So at first we really hope so. So that is the logic, and in that sense, yes, this is relevant. And on the contrary, the last two digits of the sole population registration code, we can, in this case, regarding IQ, regarding this specific measure, so people are going to have better education levels, and of course maybe they are going to be better. So what happens with exogeneity? Is this related with IQ? Maybe yes, and probably because we are omitting the ability variable. Gracias.
Es que ahora sí nos vamos a hablar. Ok, entonces, bueno, habla de lo de cada uno. Tienes que hablar ahorita.
So if I have this omitted variable or the proxy of this variable, so this could actually solve the problem, but from another point of view. So what do I mean by this? And our problem happened because we said that we had to include ability, and I did not include this because this was in the error. But maybe someone says, okay, but you are not noticing that IQ is included in your data. So we need to analyze if we think that IQ is exactly the same thing as ability, or if this includes the information that I need, then what I have is that I really solved this problem, and this was not an exogeneity problem. I am including another coefficient, and the equation that I'm going to estimate is wage equal to beta 1 plus beta 2 education plus beta 3, which is IQ. And if this solves the problem, then I'm going to have a linear regression, and this is going to solve the problem. But the thing here is that this is not an instrumental variable. This is going to solve the problem, and not because this is an instrumental variable, but because I am not including the variable in the error. So I am trying to explain this in a clear way so that you can understand the model. And of course, we know that we have variables, and these variables have information that I am going to include. For instance, sex, age, and among other. So this would be a simple regression and not a multiple regression. But the key point here is that we're talking about this variable that I really know that should be included in this model. And concerning the impact evaluation logic and this selection bias, so if we go back to the logic of just having a program, this is going to explain why I have this program, because this was not randomly assigned, and this can be actually the same motivation. That's why I am highlighting this omitted variable. So of course, proxy might solve the problem, but this is not going to be a good instrumental variable. So which one is a good instrumental variable? For instance, someone says, okay, let's consider the mother's education. So we need that this education explains, and that it is related to the education, to the kids' education, and it. So I am not saying that this is the best instrumental variable, but we are getting closer to building this instrumental variable. So we might think that the mother's education has a direct effect on the kids' education. And yes, it is not just because I think so, but there are a lot of documents and different researchers have found this information. So it is going to be very likely that the kids' education is going to be better. And this has to do with the fact that the mother guarantees that the kids have the necessary level of education level. So of course, this is going to we also have a good story of why the mother's education would have a effect on the kids' education. So this needs to be a variable that has an effect on the variable. Well, not really, only if the mother is the one who is going to negotiate the wages, or the kids' wages. For instance, if he or she is already working, and the effect, and this is maybe because it had an effect on the education level. But we do not need to include beta 3 equal to mother's education. So what happens with skills or ability? Well, we need to delve into it to guarantee and to have the necessary information. It is not very clear, and it is not very obvious, like this first example, because obviously the instrumental variable was not working. And in the other example, of course, it was not a good idea, because maybe it was correlated with the error. So in this case, we are not so sure. Maybe this is going to be relevant, and we need to think if this is correlated to to anything in the error, if this has to do with a genetic aspect. So we're getting closer to a good instrument. So I really hope that this helped you to analyze the instrumental variables. We do not know how to use it, but we're trying to understand how to use it. So before we keep going, I am going to provide another example, a more concrete example, so that we can analyze other examples and not only these textbooks examples that we have seen so far. So why do I insist in intuition? Well, because the first time and in the first session, I explained that one of the main reasons or objectives of these sessions is not only that the people who are not aware of these econometric terms or the ones who have not conducted impact evaluations, my goal is to explain the existence of these quasi-experimental models, and we're trying to build the counterfactual in another way. So it is important that you understand these methods so that when someone says, okay, I am going to explain this method, you already know what they are about. Or if you want to hire an impact evaluation, maybe the one who is conducting this evaluation is going to talk about technical terms, but you already know the terminology, you are aware of everything. And of course, if someone wants to learn more about impact evaluation, this is very important and this is going to be very helpful for you. So another example, a real example, because this is a research article trying to solve a deep or fundamental question regarding economic development. So this question has to do with this doubt regarding inequality, if inequality has a negative effect on economic development. So this is a very important question in development economy. If inequality has a negative effect on income. So if we just have the stylized facts or data, if I have a graph like the one we have in slide, this includes the Gini coefficient, and this is the most used measure when we talk about inequality. So it happens that when inequality increases, and here we have the logarithm of income per capita in many countries. So what do we see? When inequality increases, income decreases. And here we have this simple regression to relate inequality and economic development or income per capita. So how do we interpret this? Well, when inequality increases in a country, income decreases. So this is a problem that we have not covered, that we have not talked about. This has to do with simultaneity or causality. What happened first? The relationship, or what has an effect on what? So we have a problem regarding inequality because inequality is affecting income, or is it otherwise? So what comes first, the egg or the hen? What causes what? So this is the same problem. This has to do with an endogeneity problem, and this is going to have an impact in impact evaluation and concerning the different programs. So this is the same thing. If I have a simple regression, I cannot interpret this coefficient or this negative slope or fact that the coefficient decreases. This is a statistical relationship. If I draw this line, it seems that they are going in different directions. When Gini increases, income decreases, and this is not the same as causality. How do I include causality in this case? Well, we have an endogeneity problem, and of course, I have to include instrumental variables if I am going to talk about endogeneity. So the author is Easterly, and what he says is that he thinks that there is a negative effect, but he tests this. And as I was saying, it is likely that there is inverse causality, because it is not just what I want to see, and it is not that inequality has a negative effect on income, but the most rich countries actually can have distributive policies, and of course they have inequality doesn't increase. For instance, Switzerland. The logic of what we are trying to analyze, or the causality, is to be able to say that Switzerland has high income because a inequality, or maybe Switzerland has a high income and that's why inequality decreases. So I am really interested in a very specific relationship. So how do I make sure that I am measuring this and not the inverse relationship? So this is the same thing in an endogeneity problem. So what I want to highlight here, maybe this question is going to be interesting or maybe it is not. I want to talk about an instrumental variable and what usually happens in practice. The instrumental variables are generally very attractive, very appealing, because this is something that is going to happen with instrumental variables. These are things that are very surprising, and maybe when and many people do not understand what is an instrumental variable. And well, the first thing is to say no, this is not going to work, this is nonsense. But before we do this, we need to be able to say, or to be able to measure, or how to analyze an instrumental variable. That's why we're doing this. So we are going to talk about this variable that is going to surprise you. And it's what Easterly does is that he says, I am going to analyze the ratio or the algorithm. And then we have information, for instance, the land surface of a country with specific characteristics. So I can, so wait, and the land surface that could be sown with sugarcane. So we have a ratio in this case, for instance, area that can include wheat and the one that can include sugarcane. So first we say, okay, why can this be a good instrumental variable? And what we have to do here, if you do not know what you are doing, we need to analyze the information so that this can be a good instrument. So what I wanted was, what do I need? And I am trying to explain the inequality effect on income. So I have this endogenous variable. So I also need an instrument, and the instrument must be related to inequality. So I need a variable that is related to inequality, and this variable should not have a direct relationship to the y variable that I want to measure. And why this ratio is related to inequality? Well, what they do is that this is not something that they are just coming up with. They have literature, broad literature, empirical and theoretical, that talks about the central role that initial factor endowment has over inequality. And of course, there is a lot of scientific and evidence, theoretical and empirical, that says that inequality is a phenomenon that moves slow. So we can have the historical roots of inequality, and specifically, this empirical information says that the places where sugarcane could be sown, for instance, places where wheat was planted were compatible with family farms, and therefore this gave rise to a broad middle class. So, of course, in the other case, places where sugarcane was planted gave rise to economies of scale, use of slaves, and therefore high levels of inequality. And of course, this led to higher levels of inequality. And in addition, as I said before, the other aspect of this variable, it was easier to have small farms or family farms regarding the land size and its production. So that's why this gave rise to a broad middle class. So Easterly says that what we are seeing is that today's inequality, not 100%, but we need to have a correlation. So the inequality that we see today can be explained by the initial factor endowment. So this can be explained. Of course, I need just a part regarding inequality. So this has to do with agricultural matters. from 100 years ago. So that's why they said that this is relevant. So we have the theory, and also when they analyze it, the information, they say that okay, maybe this seems to be true. And this relationship between, when we go to the other side, wheat ratio increases. So these places that have more wheat, or the wheat that can be sown, are places that actually have low Gini coefficients. So if there is a lot of land area that can be sown with wheat, and today we have countries with low inequality levels, and in the countries where this ratio was very small, or where the land surface could be sown with sugarcane, these places had high inequality levels. So from a statistical point of view, we can see that there is a relationship, and also from a theoretical point of view, because there is a lot of evidence and theory that supports this. So exogeneity, I can send the reference of the article later, but it has to do that today the things that were very important 100 years ago are no longer important. This explains inequality, because this is a phenomenon that moves very slow. But we need to analyze the ratio, the land ratio that can be used for wheat or sugarcane. So this article has to do, it was written in 2000, and it says that it is not going to have a direct effect on income.
You are currently
So
the only
in
person
this
in
case,
this conference.
or in that sense, we say that the relevant instrument, we already have a story, and we can explain why it is exogenous, because this historical variable affected inequality. So that is the construction, or the how we develop this argument. But I am going to explain a bit more concerning instruments, and I am just explaining what this is. So there is a question regarding a statistical evaluation, or if an evaluation can detect impacts. This is not what this has to do with randomization. When we are designing a random trial or a random program, we need to guarantee that we have enough power, or that I am going to be able to detect the size of the effect. And the relevance of this is that I need to define the sample size, the minimum sample size that is going to receive the treatment, or the minimum household number, or companies or communities, to be able to detect from a statistical point of view a change due to the program. So what I am talking here is something different. This has to do with causality, and causality is not going to be solved by sample size. Causality in this example, in this inequality example, it doesn't matter that it has many countries or less countries. I need to understand what happened first. For instance, regarding education and wage, this is not a sample case. This is rather a how we develop this logic. If I omit a variable, I do not know if the beta that I am currently measuring is capturing the effect of the variable or not. So this is something deeper and more important. I think that causality is way more important, because it is more complicated to be solved. Or maybe I need an experimental method, and then I control from the origin that this is a random program, and there are no omitted variables, and nothing should affect anyone in the program. But if I have a random program, then of course I have to worry and I need to guarantee that I have enough a sample size. And if this is not a random program, then I need to guarantee that some of the methods that I am currently explaining, and I need to include one of these methods to talk about causality. So I really hope that this answered your questions, and I really hope that you clearly understand what is an instrument, how do I know if this is valid or not, the characteristic that it must have. And once I did this, okay, so where do I get the instruments? Who is going to help me to get them, or how do I solve these problems? There are different sources. The first one is nature. So what do I mean by nature, and why is it important? Well, because we need to have an exogenous variation. So if the influence of x and the instrumental variable is something exogenous, then of course this is going to be great, because y cannot affect the instrumental variable. And a perfect example was the one that I previously explained. This is a relationship of history and nature, because the biophysical characteristics of the land allow to sow specific crops. And also we have this historic aspect. There are some characteristics in the past that could have an effect of y, but they do not longer have an effect on y. So if I want to measure the income 200 years ago, well, clearly I need to measure how much they were able to produce regarding wheat and sugar cane, and that's why it had an effect on inequality. But this is not important today because it doesn't have an effect on income, just inequality. And the most important or interesting one is institutions. And at the end, when I keep talking about instrumental variables, I am going to make sure to talk about institutions, because this is very important in this case. So what do I mean by this? Well, there are rules, customs, and some characteristics that determine who received or who not received treatment. And in some contexts, some of these rules can become an instrumental variable. So I am going to explain this in further detail when we see the example. So I really hope that this is really clear. So the design of the program or policy can have possible instrumental variables that we can use. So we are going to explain why is it useful, or how do we use an instrumental variable. So far what we have seen is that there is a problem with ordinary least squares. If I had this regression, the one that I was previously explaining, then we had a problem because the endogenous variable could not talk about causality. But now what we want to analyze is the new model. I am going to talk about the technical aspect, but I am also going to explain intuition and why the instrumental variable solves the problem, and why the assumptions behind this are very, very important. So we are going to talk about this case where we have one variable, and this is x. And then we have an instrumental variable known as z. So this is the context that we have been explaining so far, and I really hope that you can be a bit more patient regarding this technical aspect, because now later we're going to talk about intuition, and here we're going to have the momentum method to be able to use this variable. So what happens? I have information regarding Z, or the variable of interest, education, for instance. This has an effect on X, which is education, for instance, the mother's education. Maybe this was a good instrument. And this has an effect on Y, which is wage. And I have this information. I want to use this information to have a consistent estimator, beta 2 estimator. So I want to have an estimator that can measure the causal effect. So I need to interpret this beta 2 in causal terms. So I need to analyze the effect that is going to have on the causal effect, for instance, on Y. So how do I use this information? Well, it happens that I need to include covariance. So that's why covariance is a very important thing. So I need to include this regression, and then I include covariance. So in this regression, I use not only y, but covariance between z and y. So this is a constant, and that's why this is going to disappear. So covariance between z and y, and covariance between z and y. And u, sorry. So we already know what is y, and I need to analyze the covariance between z and y. So I have this expression. So with this expression, maybe I know something about this. I am assuming that Z is a good instrument. So what does it mean that this is a good instrument? This means that covariance between Z and U is equal to 0 because Z is not related to the error. And besides, this has to be relevant. So a good instrument means that covariance between Z and 0 is different from 0. So why is it important? Well, because this allows to say, okay, this is equal to 0. Okay, I cancel this. And then I can divide covariance of Z and X and Z and Y. So using these assumptions, I can say that this is an alternative formula to obtain beta 2. And I am using information concerning Z, X, and Y. And it happens that the information that this concerning this instrumental variable is going to allow to use this, and this is going to include causality. So in this way, we use the instrumental variable, and this is going to include causality. It is not evident so far, and that's why I am going to talk about the intuitive part later on. But here I want to explain the formula. Maybe some of you are already aware of these formulas, but the important part here is the intuitive part, and also the assumptions that we have seen so far are necessary, because thanks to it, I can have this formula. If I have information, I am going to be able to estimate this, but this is going to estimate what I want to estimate only if covariance between Z and U is equal to 0. If this assumption is met, then this formula that could be estimated with information is approximating beta 2.
You are currently the only
Or
person in this
if
conference.
this is not 0, I cannot include the formula that I have below. And these are the identification assumptions. So if I have information, I can generalize this, and this was just one variable because we had only one X, and I have said that this is not a very interesting case. This is not going to be something very common. Of course, I am going to have more variables, and in this case we only had one. It was very easy to just include one in the slides. So this can be something more. This can include more variables or X. But if you are aware of this, this is a two-stage least squares model. This is what we have previously seen. And in this case, we do not only have one X, but many X's. And also we have an indigeneity problem that I am going to solve with instrumental variables. So this model works in 2 stages. The first thing that I am going to do is to use my instrumental variables to be able to have an estimation of X. So this is X, and instead of using X, I am going to use the X forecast, sorry. So this is going to be explained in a diagram so that we can understand this in a better way. So in the diagram, this is the variable that I wanted to explain. This is just one variable. So I'm going to try to use this pencil to draw in the computer. No, that's not going to work. I am going to explain this because this pencil doesn't work. So here I have just one variable. So I want to explain y by using x. So that's why we have here this part here. So I want to explain y using x. So what we have here, this is the common area, or this is the common information between both. So this yellow area includes the error. So this is not related to x. So remember that my objective is to have a regression where I can use the x variable to explain the y variable. And this error area, the yellow area includes the error. So here I use the common information between x and y to obtain the effect of x on y or beta 2, and it works. But the endogeneity problem that we have here, maybe we can analyze this with diagrams, and this can be seen as a problem where error is no longer the yellow part, but error in this case is the yellow and the red area. And what does it mean? And this means that this is just a small part, the red area, and this is related to x and y. So this is the endogeneity problem because the red area is in x. So we can see here that the red area is common to both areas. So when we are using a regression, I use this information to try to explain y. But part of that information not only includes x, but also the error. So I do not know if what I am explaining has to do with the error on x or the error on y. So this part is the purple and the blue areas do not include the error. The error was included in the red area. So here we had a linear regression, x against y. But if I am now doing this and if I am using the information of y to explain x, then I have an error component. So now we say that we are going to include the instrumental variable. So this is a good instrument. Well, what we have here in this instrumental variable is that it is related to x. There is an overlapping between z and x. So it is relevant. And it is exogenous because this is not correlated to the error. Remember that we said that the error was the yellow and the red areas. So the error there is an overlapping on x. So first, this is a good instrumental variable. So how does it work? How does the instrumental variable work? And here we have the two-stage list or ordinary least squares. So in the first stage, we're going to use z to try to explain x. So this is the first step. And I'm going to use this information between z and x. So I have a regression of x against z. But the one that I am interested in is a regression of z against x. So first I'm going to do the first one, and this is a regression that I am going to use in a temporary way. Let me see if... So first I am going to have a regression of x equal to a plus beta per z. So I am saying that in the first stage, I am going to have a regression where I have the following. I am going to use z to explain x. So we're doing this. So the common area between z and x to explain x. And also I have this part, and with this information I have a forecast of x, and this forecast is the part of x that I can explain by using z. So what do I mean by this? Well, I am going to use this relationship or ratio, and what I am going to explain. So I am trying to have this regression. I am going to use z to explain x. So what part of x can be explained by z? Well, only the common area, the orange area, and everything that is outside the blue and the red area are not related to Z. But if I only use Z to explain X, then the part of X that I'm going to be able to explain is this purple and orange part. So I really hope that this is clear for you. I'm going to repeat this. If I want to use Z to explain X, this is the only part of X that I can use by using Z. This cannot be used because Z doesn't provide any information on this area or this area. So this is known as the first stage, explaining one part of X by using Z. And this instrumental variable model in the second stage, it uses the regression of interest. So I am going to have the original regression, y is equal to, I am going to have other letters, beta 1 plus beta 2 equal to x. This is going to be difficult to draw, but this is not going to be set. Maybe it's a bit complicated for you. Just give me 1 second. I am trying to draw this so that you can see this. Okay, we're going to have, this is the regression of interest. And the difference here is that I am not going to use, this is the forecast in the first stage. So in the first stage, I used Z to explain X. And this X includes everything. So this is not X because this cannot explain this or that. So this X part, I could explain this part. So this X includes this part. And what I'm going to do is that I'm going to use this to explain Y. So what happens in this case? Well, I had a problem when I was using X to explain Y. And I had this problem because I was including this red area, and I was making a mistake because this area was correlated to the error. So I had this instrumental variable, and so it happens that after the first stage, I am going to use X star to explain Y. And what is the advantage? Well, because I do not have the red area, so I am using less information concerning X. But by doing this, I am losing a very important area, but also I am not including the area that was related to the error. So this is an instrumental variable. An instrumental variable helps me to keep the exogenous variation or the X variation that is not related to the error. And how do I know this? Well, because this is the assumption concerning the instrumental variable, and the instrumental variable is exogenous. So if I am using an exogenous variable to explain X, what I am explaining concerning X has to be exogenous. So this is very important. This is the intuitive part of the model. So I really hope that this was clear for you. So try to analyze the diagram if you do not understand this. But if I only have the exogenous part and I do not have the error, that's why this model includes 2 stages. First, I get rid of the endogenous part, and in the second stage, I only include the exogenous part concerning this variable X to obtain the coefficient of interest. So here we have a question, and I think that this is a very relevant question because this X, I am, of course, having less information and I am not explaining that much in comparison when I have the X, because this was explaining the full relationship between X and Y. And X star is just explaining less information or including less information. So this information is not endogenous, so I can talk about causality. This also provides an advantage because this includes a smaller part of X. So this is the technical aspect, and of course, we need a lot more time to be able to talk about this, but we need to be very careful concerning the causal result that we are going to measure. And this is very important in impact evaluation. I am going to leave this, but this is fundamental. It is fundamental to understand that I have less information. Therefore, the impact evaluation is going to be valid for a specific subset. So in literature, this is known as local average treatment effect. I cannot find this effect with other instrumental variables, but this is just the effect of the program concerning a specific part of the population. We do not have enough time to explain this, but when we have less information, I'm going to lose something. I am going to talk about causality, but this is going to include a specific subset. Of course, there are some technical trials that we need to conduct. We need to conduct an endogeneity trial. If there was an omitted variable, we also need to have an exogeneity test of the instruments, and this is possible when we have more instruments than endogenous variables. So I can try to conduct an exogeneity test. And the last one has to do with weak instruments. So I am going to leave this so that you can check, or for instance, if you have to conduct these tests when you are conducting an impact evaluation. So to explain this, the weak instruments, we have an instrument that is relevant. And by relevant, this means that there is correlation between Z and X. So in this case, this instrument is not relevant because Z and X are not related. And weak instruments has to do with more subtle things. And what do I mean by weak? Well, how small has to be this area? This is the area. If I am only using X star to explain Y, this is the area that I am going to explain. So how small is the area? So this might seem enough. Maybe this is already a weak instrument because it is relevant, but it is not that correlated. So it doesn't explain a lot. And it is important to keep this in mind. This idea, we have to conduct an additional test concerning exogeneity and relevance, and also we need to conduct a test concerning weak instruments. So if this is related to relevance, this is an instrument that is not relevant. This is not like the example of the last two digits or the random variables. So it is not relevant. It is easy to get rid of this. It is more complicated. If, for instance, if the relationship is weak or strong, or if I need a stronger relationship like this one. So this is a test that we need to conduct. So let me try to explain this, and I'm going to talk about randomization. When we were talking about randomization in the previous session, we were talking about fulfillment. So in my computer, for instance, I was selecting the individuals who were going to receive treatment, or maybe the policy was going to be implemented. And if I said that this was going to be a control group, then maybe this control group would not receive treatment. So what I am defining is the control group, the treatment group, and in practice, this is fulfilled. So in reality, this is something very, very complicated because many times fulfillment is not perfect. And what does this mean? Well, for instance, imagine that you were conducting a random program. You guarantee that you made sure that you had a sample size, but when you are implementing this program, you start realizing that there are some individuals in the control group that start receiving the treatment, or maybe otherwise. So what happens? Well, this is bad news because we cannot have a difference in means as previously done. But in this case, we can use an instrumental variable because I can use randomization as an instrumental variable. So how does this work? Well, I want to analyze the effect of treatment on a y variable, or what is the effect of having treatment or receiving treatment in a variable of interest. Y can be income, health, or other things. And y can be an instrumental variable because this is going to meet the exogeneity assumption because it included randomization and it doesn't have to affect y or be related to the error. This is going to be relevant. Well, yes, because I am trying to explain randomization and participation in the program. So even if there is contamination, we really hope that randomization was conducted. For instance, 90% of the ones who were supposed to receive treatment and only 10% of the control group received treatment. So of course there is a high correlation between what I am defining from a random point of view and what happened. So of course it is relevant. Randomization is going to help me to explain who was included in the program, who was not. But I really need correlation. So randomization can be used as an instrumental variable because it is random, so it is exogenous, and also because it is related to the ones who are receiving treatment and the ones who are not. So I need to have a difference in means and also instrumental variables, which is randomization, and then I am going to be able to develop everything and including randomization because I had an instrument. This is something that I needed. I had it in the necessary information for this instrument. So before moving forward, in order to guarantee or create the instrumental variable, we need to guarantee that this doesn't include the error. And yes, this is fundamental because this has to meet the assumption and the instrumental variable. If this is not met, then this is not a good instrumental variable. And concerning this example, that's why randomization can be very useful. So these rules or institutional matters, someone who is working from a computer knows who was assigned treatment or control. And then you also have the necessary information of the ones who receive treatment and the ones who doesn't. And what happens with the results variables. But in my computer, for instance, this is the instrumental variables. This is exogenous because I designed this in a random way. Another possible use that has to do with randomization and instrumental variables. So how can we have an instrumental variable from the beginning? Well, maybe in some contexts, it is not going to be possible to have randomization because maybe this is a coverage program. So of course I cannot deny access to this program. Maybe I can say, okay, because I want to evaluate this, then I would like to have an instrumental variable. And something that has been done is randomization concerning the promotion of the program. So I can say, for instance, that everyone has access to the program, but I am going to say to select the individuals in a random way. I am going to choose different communities, and then I am going to promote the program, and in others I am not. So what would we in the places where I am currently promoting the program, participation is going to increase, and thus I am generating an instrumental variable because this has to do with random assignment, or this is exogenous promotion, and of course the instrumental variable is going to be exogenous. It is not related to anything because people did not choose promotion. I randomly selected promotion, and well, because if, for instance, if someone who receives who is aware of the program, then this is going to increase the probability of being included in the program, because this can explain why someone has the program, but maybe he or she is not related to the variables or the ones who are affecting y. So these are two ways in which we can use instrumental variables, maybe because randomization was not conducted in a good way, or maybe I randomized promotion and not assignment. So clearly, instrumental variables are, I really hope that you understand that it is very, very hard to find valid instruments, because statistical tests sometimes have their own problems. For instance, if the assumption is not met. So what I wanted to have is no longer possible, and I can have this additional thing. I am including a small population group. So in this case, this is just a way of doing this, or a way of using data, so I can have instrumental variables to develop a counterfactual to solve the problem concerning randomization, or when I randomized promotion. Or an endogenous variable, we can use instrumental variables. So this is one of the many things that we can use. And another thing has to do with panel data. We are going to talk about X endogeneity, but in this case, this is not instrumental variable. We're going to talk about something else. So let me talk about this. We have enough time to talk about this. So we have two types of information: panel data and repeated cross-sectional data. So what do we mean by repeated cross-sectional? Well, this means that I have a random sample which represents a population, for instance, a household survey in 2000, and this represents my country. And after, in 2010, I conduct another household survey, which also represents the country, but this includes different households. So observations are independent between both periods. In 2000, I have a representative sample of households, and in 2010, I have the same sample, but without different households. So the other type of data includes panel data, because I have survey conducted in 2000, and I try to follow up on those households in 2010. So let's suppose that in 2000 I have 1,000 surveys, to 2,000 surveys, and in 2010 I try to follow up on those households. But for instance, I have 900 or 950. So here I have 900 households, a household that I included in 2000, and I am including the same household in 2010. So that is the difference between panel data and repeated cross-sectional data. So we're going to talk about how we can use this. So we're going to start with cross-sectional data. And I am going to use this to talk about impact evaluation, and that you might have heard. And this has to do with the DID method, or difference in differences. So let's talk about this, and if we do not have enough time, we can talk about this on Thursday. So I have this cross-sectional data. I have two random samples, year 0 and year 1. Besides, I have two groups. One receives the policy, program, or treatment in period 1. No one receives anything in period 0. There is a group in period 1. And then I have the control group. So I have year 0, year 1, a group that eventually is going to receive treatment in year 0. So we have 2 points in time. We have two groups, a control group and a treatment group. So how can we use this information? Well, we're going to define what we have talked about. W is going to be 0 if this is going to be in the control group, and 1 if this is going to be in the treatment group. So I am interested in a y variable, so I can define 4 expected variables, or 4 averages this includes income for control group in year 0, income for control group in year 0, income for treatment group in year 0, and income for treatment group in year 1. So I have information for the control group and for the treatment group in year 0 and year 1. So I can have these 4 expected values concerning the average income. So what do I do with this? We have already talked about this. I have previously explained this. This was the example concerning the previous section. So how can I measure the impact of treatment using this repeated cross-sectional data? Well, I can just forget about the control group. I can only include the treatment group. And previously, this is what we have explained, and this is the before and data comparison. So how was income in year 0 for the one who's going to receive treatment, and how is income in year 0? These are not the same individuals, but these are representative samples concerning the same population. So this is the same thing just as before and after comparison. So we already analyzed the problem. Maybe many things are going to change through time, but maybe I do not know if this change in Y is due to the program or maybe to many other things that changed through time. For instance, if the economy increased, if there was a hurricane or some weather problems. Of course, many things are going to change over time. So, of course, if I have a before and after comparison, I cannot say that this was the effect of the program. But everything that changed between years 0 and 1 can explain why. And of course, this is not going to be satisfactory. So maybe one can say that the time is creating more problems. So we're going to compare the treatment group and the control group. We are going to compare these two averages. So the problem here, we have already talked about this specific case. And between these two groups, there can be some differences due to other things. Not only to a program, but other differences that already existed between both groups. And this is the example that I previously explained in the previous session, or in the first session, I do not remember. And this was the difference between schools with textbooks and schools without textbooks. So here we would be analyzing performance in schools with textbooks and without textbooks. So this difference is not only due to textbooks, of course. This has to do with not having a counterfactual. In this case, we do not have a counterfactual. Control group is not a perfect counterfactual of the treatment group, because here we are not talking about randomization. So this is not, the individuals were not randomly selected. And in this case, the same population group is not the same because, of course, things changed over time. So this is another way of analyzing this. This is control treatment and before and after comparison. So, of course, we do not have a valid counterfactual, but which one is a valid counterfactual? And I am going to, this is only the introduction, and I am going to explain this in further detail in the next sessions. So a possible counterfactual, and this is known as difference in differences. And maybe this sounds a bit weird. How do we use this? How do we make this? But honestly, this is just subtracting. This is difference in differences. So what do? We have the difference between both groups in year 0 and difference between both groups in year 0. And then we calculate the difference. So we are going to subtract this. I am analyzing how different were groups in year 0 and in year 1. And this is what we know as difference in differences. So what is intuition? And this is what I'm going to explain in the next session. So in this case, what we are saying is, in this case, program did not exist, and maybe groups were completely different. So that's why I am considering this first difference. Let's suppose we're talking about income. So income concerning treatment group without program, because in year 0 neither have program. So we take this difference, and in average, treatment group has an income equal to more than $100 in comparison with the control group. So the difference is equal to $100. This is an intrinsic difference for both groups. So then time passes by, and I measured this difference between both groups again, and now the difference is no longer $100. So after the program was implemented, the difference is equal to $120. So this group has an income, and if I have this difference, 120 minus 100 is equal to 20. So this is difference in differences. So the intuition behind this is that we are saying that this group had an average difference of $100. So when you implemented the program, this difference changed, and now it is equal to 120. So the difference due to the program is not only 120, because they had they were gaining $100 extra. So the difference in differences is equal to 20%. So this difference becomes a sort of counterfactual. They were not the same, but I already know how different they were, and that was $100 in average. And now we have $120. But if what changed was due to the program, then of course I can attribute this to the program. So I think that this is a good time to wrap up, because we do not have enough time. So we're going to talk about this in the following session. On Thursday, we're going to talk about intuition and difference in differences, and we are going to analyze the following points. We're going to tackle the intuitive aspect, but you already have the formula, and the key is that I am controlling how different they were before the program, so I can see if this difference changed, and I am going to see if this can be attributed to the program. Okay, so with this, I want to end for today. And in the next sessions, we're going to talk about difference in differences and the other methods that we are also going to talk, propensity score matches and discontinuity and other methods. So we're going to talk about these quasi-experimental methods in the following session. Thank you very much for your time and for being here, and have a great day. Bye.